Okay, so in this video here, what we're going to do is this is using code that's very similar to the code that we used in the previous video, showing you how to drive to a commanded number of millimeters. Here we're going to be able to show you how to turn for a commanded number of degrees. And when we say degrees, we're talking about degrees of rotation, not degrees of the motors. Not how many degrees the motors turn, but how many degrees the robot turns. So if we look over here at our steering block, this was always set to a 0, the steering value, when we were driving straight forward. Here what we're going to do, we're actually going to set it to a value of 100, and we're going to put it to the right, so a positive 100, which is going to mean the tightest turn we can possibly do towards the right. And what that will make it do is it'll make the robot basically just spin in place in a clockwise direction. So this is basically the same code block we were using in the previous video for driving to enough number of millimeters. So what we need to figure out now is how many commanded motor degrees is basically equal to one robot spinning degree. And we don't really have a formula to do this or a way to measure. Basically what we're going to do is kind of a trial and error method. So I'm going to set this to spinning for 1000, and this B value, this scaling value here, I'm going to change this back to 1. I'll do this here. So this should make us turn okay, we're going to try this here. So this is just showing what this means when we're spinning. So you can see that is spinning in a clockwise or right hand turn direction. And every time I run this, you'll see the left wheel is basically spinning forward and the right wheel is spinning backwards, and we are rotating. Basically, if you drew a line directly down through where the middle of the axle is between the right and left wheel, that's basically, that spot is sitting still. Everything else is just rotating. I find this turn is the best one to use in FLL for navigating, because your robot's really not moving when you do this. It's basically just spinning in one place and changing direction. You're not moving forward, not moving backward when you do it. You're basically just spinning, and you're not really interfering with anything else that's on the FLL field. So this spinning in one spot turn is the way that I like to be able to turn. So we need to figure out what should the scaling value be, so that when we put in a value in degrees, it actually turns that number of degrees. So we're basically going to use a trial and error method to figure this out. So I'm doing voiceover narration here. So we'll see when I actually go back and change this. So I'm going to change this to a value of 360. And then change this B scaling value to a value of 1. So that B value is basically what we need to figure out. What is a good value to put in there? So right now this is going to do 360 times 1 is going to be the number of degrees we're going to rotate for the motors. And we're going to figure out how much does that actually make the robot turn. And then we're going to keep on changing that B value until we find a value we like. So we're going to run this. So we're trying to make it turn 360 degrees altogether. Okay, that looks like it turned a little over 180. So we need to go about double that. So let's change this B value to a 2 and see what that does. So there's 2, so we're going to try that same test again. So 2, not quite there. So let's try a little bit more. I think the next one we're going to try will be 2.1. And we're basically just going to keep on doing this until we find a value here that we think is working pretty well. So that one looks like it just overshot by a little bit. So we're just going to dial it back just slightly. I think we're going to go with 2.08. We'll try that. We're basically just going to keep on taking shots in the dark here on the dartboard until we hit something. All right, that looks like it's pretty good for at least for the purposes that we're going to do today. 2.08 looks like it works pretty well. So we will try that. So we're going to use 2.08 as our number that we're going to leave in there. So I think we're just going to, we'll comment this code here. Now I don't know if there's a reason why the previous code that we did for driving for millimeters, scaling value we used was 2.092, which is awfully close to this one we just figured out now. I don't know if that's just a coincidence or if there's a reason for that, but this is what we just figured out here. So we're just going to put this comment in here so we can tell what we're doing. When we look at this block again, should always comment everything that you do. It's a good habit to get into. It's a good habit to get your kids on your FLL team into. So now when someone opens up this code, they can tell kind of what's going on. All right, so that is our nicely commented block. Now we should be able to test this out to see if it works. We did it for 360. What we're going to do is now any value we put in A, that's how much we should turn. So if we put a different value in there, so for example, if we want to put in a 90, if we wanted to turn to the left, we put in a negative value. You put a negative 90 in there. We're just going to put it in a 90. That should make it turn to the right. And if we run this, we should see it do a 90-degree right-hand turn. All right, it looks pretty good. All right, so that is basically some code that lets you turn. There's our negative 90. That should turn back. Negative 90 should turn 90 degrees to the left. Not completely accurate, but pretty close. So this is code that basically lets you put in a value in degrees of robot rotation, and your robot should turn by that amount. So pretty simple piece of code. In the next video, I'm going to show you how to convert this into a My block and be able to use those blocks.